Hi everyone, Brenda Gustin here, and I'm in section 1.2. I wanted to talk about a little bit of history of microbiology. You can imagine I can only do a little bit because there's a lot of it to be had. But where I wanted to go was from the discovery of microorganisms to the understanding and the acceptance of the germ theory of disease. And I think you'll be surprised of how long this period took. So you can look on your lecture handout and you can see the main scientists that I'd like to for you to be aware of. But I'm not going to talk about this section on spontaneous generations, but you already have a feeling for even if you didn't know any microbiology, you'd be aware that food spoiled. And so people for hundreds of years have known that food spoils if you don't eat it right away or you don't store it in the right way, that food is going to spoil. Now, people didn't necessarily know what food spoilage was. They just knew it was no longer safe. It was no longer edible. It didn't taste good or it made you sick. They weren't aware that microorganisms played a role. People also made products like wine and cheese and yogurt and kimchi and other fermented foods. And again, they had techniques on how to make those foods, but they didn't know that microorganisms were involved. They didn't know you had to add, that microorganisms were in the natural environments and were used to make those foods. So there was a lot of action going on with microorganisms before we even knew they existed. So the first video I want to show you is from a movie called Mavericks, Miracles, in Medicine. It's actually a book and there's a video on YouTube. You can find the whole, couple hour long movie on Mavericks, Miracles, in Medicine. And it's on the history of medicine, which includes a lot of microbiology and lots of really cool medical things. So if you want to find that, but I'm going to show you two videos. I think each is about 5 minutes long. The first one is on Antony van Leeuwenhoek, and he's this person who discovered microorganisms. Come on.
Van Leeuwenhoek is a glaring exception. Totally unschooled
in medicine or science, he made his extraordinary discoveries using only his eyes, his imagination, and a tiny hand-fashioned microscope.
Interesting thing about van Leeuwenhoek was that by occupation he was a draper. He had a quaint draper's store and he was also a part-time janitor. And the thing is this, he became interested in making microscopes.
Anton van Leeuwenhoek was born and raised in the small Dutch town of Delft in the latter half of the 1600s. At the age of 30, he began grinding lenses and making rudimentary microscopes as a hobby.
Most people do believe that van Leeuwenhoek invented the microscope. Actually, Zacharias Janssen was the first to describe the principles of the microscope in 1590. For 50 years, in fact, before van Leeuwenhoek, people were looking through microscopes. There was a big difference in that what everyone else was looking at were things that they could see with their eyes, and they were just using the microscope to look at them more clearly.
What Leeuwenhoek did was much more remarkable.
He first started grinding lenses. Why? Who knows? This comes from a deep part of his being that you can't explain. And then he had the sense to use these lenses to look where no one had looked before. If you can make any principle about making a scientific discovery, one of them is to use a new instrument, to look where people haven't looked before. And this was exactly what Leeuwenhoek had done and what he did. And what he found was quite surprising.
He decided to look at some rainwater that had stood for several days. And when he looked there, he was absolutely amazed. He saw little animals that were moving around from place to place. And he was absolutely amazed.
He looked at semen, at pond scum, and he found and identified many different types of organisms.
He looked at his own blood and saw for the first time red blood cells. In addition to that, he looked at his own semen. And then he saw these little strange wiggling creatures in there, which he described.
A natural-born researcher, he meticulously documented what he found. And in the early 1670s, he began writing letters to the Royal Society in London describing his work. One letter began, "I discovered little creatures in rain, which had stood but a few days in a new tub that was painted blue within." He went on to describe all the incredible were less than receptive.
Professional scientists are always contemptuous of people they consider to be interlopers. It was no different in Leeuwenhoek's time than it is today. Here was a man, a draper in Holland, not known to these people in London who had made their names in science. What are they going to think?
The members of the society reacted with thinly veiled hostility. "Here is this letter from this unlearned Dutch draper whom we really don't know," they wrote, in which he claims to have detected thousands of animals in a tiny drop of rainwater. He must send us verification of these findings by others whom we can trust.
So all the notables of the town came and looked through the microscope, including his clergymen and so on. They then wrote a letter to the Royal Society and said that what he was saying was true.
When he showed his guests vinegar under the microscope, some of them were so disgusted by the spectacle that they vowed they'd never use vinegar again. Leeuwenhoek would later write, "What if one should tell such people in future that there are more animals living in the scum on the teeth in a man's mouth than there are men in the whole kingdom?" Even if they found Leeuwenhoek's discoveries disgusting, everyone wanted to peek into the world hiding under his microscope.
Royalty from all over Europe visited his draper's shop in order to look through his microscope and to see the invisible world. And in fact, Queen Mary of England visited his draper's shop to come and look through his microscope.
Finally, after Leeuwenhoek had submitted dozens of papers to the Royal Society, and Robert Hooke, the Society's own microscopist, confirmed Leeuwenhoek's findings, the august body which had originally shunned him accepted him as one of their own.
He was the only uneducated draper and part-time janitor ever to become a Fellow of the Royal Society of London.
But it would take 200 years until Robert Koch proved the germ theory of disease for the world to understand the significance of the organisms that populated the world Leeuwenhoek saw under his microscope.
So we have Leeuwenhoek discovering microorganisms in like late 1600s, and but at that time they really didn't know what to think about it other than they were there. So we're going to get to the next step. We're now at 1847. So 150 years later, 1847, and Ignaz Semmelweis. I'm going to show you another video.
Was its most famous hospital. There, young Semmelweis was a resident in charge of the first obstetrical clinic. For months, he had been tortured by a problem. Many of the new mothers under his care were dying of a disease known as childbed fever.
There were hundreds of thousands of mothers dying in Europe every single year. No one knew why. So that became the great puzzle that all of the professors of obstetrics in Europe were looking at and had come up with all sorts of ideas about.
Some believed their illness was caused by fear, others that it had to do with whether or not the young women were married, and still others that it might be caused by some mysterious halo clinging to the doctors. Whatever the cause, Semmelweis became determined to find it. The first thing he noticed was particularly perplexing.
What was strange about it was that there were two lying-in clinics, one of which was handled mainly by the physicians of the day, and the other by the midwives. The clinic that was handled mainly by midwives had a much lower rate of death among these poor women.
Semmelweis was confounded by this difference. What was it about the doctor's ward that made the death rate so much higher? He set about conducting a series of experiments, but he was unable to isolate the cause, and the death rate in his ward kept on growing. Semmelweis was despondent. Then one day, in the kind of accident that characterizes so much of medical discovery, he found his solution.
He had a colleague named Kolechka who nicked his finger on an autopsy of one of these women, and Kolechka became infected and died. And so even though Semmelweis didn't know anything about germs or germ theory of disease, he suddenly realized that there was some type of a poison that was causing this condition.
Semmelweis saw in a flash of clarity what was happening.
So these students would go and perform these autopsies on these dead women, and they would stick their hands into the wounds. They saw no reason to wash the gunk off their hands. They would go into the students' ward and examine these women who had just given birth and who had these open wounds from the delivery.
So the doctors were carrying the germs from one patient to another on their dirty hands. They were killing their own patients. Semmelweis would write to a colleague, "God only knows the number of women I have consigned prematurely to the grave." Semmelweis lost no time in instituting a strict cleanliness policy in his ward, forcing all the doctors to wash their hands in a potent solution of chlorinated lime. Almost immediately, the death rate began to drop, apparent proof that Semmelweis was right. But far from making him a hero, his revelation was angrily rejected by his colleagues.
There were a series of reasons that could not possibly be accepted, and one of them was that to really understand this concept, you had to know certain principles of science that hadn't yet been discovered.
I mean, today it's very easy for us to look at this and say, oh, weren't they stupid? What a terrible thing. But this was the way this was done in the 19th century. No one thought there was anything wrong with it.
Semmelweis let them know in no uncertain terms that there was, and that they were to blame for the women's deaths.
So you get this man in their midst telling them all that they were murderers, and by refusing to accept his doctrine, that they were just going to kill more women and had been killing women always since the beginnings of their careers. So he was reviled.
Facing scorn and ridicule, Semmelweis sank into a deep depression. He quit his job and returned to Hungary.
Well, you know, sometimes it's very bad to be right. But when you're right, and the rightness of what you've discovered makes others feel guilty, and you throw it in their faces instead of presenting it to them either scientifically or perhaps diplomatically, you can expect that the roof is going to cave in on your head.
In Semmelweis's case, one might well say that it did. The medical establishment rejected his accusations as the ravings of a lunatic, and in the end, he did lose his mind and died a broken man in a mental institution. It was 30 years after his death that he finally received the recognition he deserved. The Viennese who had reviled him claimed him as one of their own, and the Hungarians memorialized him in his hometown of Pest.
A statue was erected in his honor, and the statue shows him standing tall with a book under his arm and a newly delivered mother sitting at his feet, holding a child and looking up adoringly at him.
He actually did make a significant discovery, but it was left to others, to finally adopt it. He's one of the great tragic figures in medicine.
So Leeuwenhoek discovers microorganisms, late 1600s. Semmelweis in 1847 tells people to wash their hands. It helps reduce maternal death, and it's not widely accepted because of maybe his bedside manner, but also he didn't have a great reason to tell people to do this. Remember, he's still at the point that they haven't connected the fact that microorganisms and disease have a connection. So what happened? We have another important scientist from history, Louis Pasteur, and he actually did many things. Among them, one of the first notable things in microbiology is helping us prove the germ theory of disease. And I'm going to go back to a picture of wine because in the first experiment, that microbiology experiment that Louis Pasteur did, is winemakers were trying to figure out why sometimes when you made wine, it turned into, your grape juice turned into wine, you got alcohol, and you got a product that you were trying to get. But sometimes it would spoil and it would turn into vinegar. And Pasteur looked at the wine under the microscope, the normal wine and the wine that turned into vinegar, and he saw microorganisms. And so the question was, do the microorganisms make the wine, or does the wine cause the formation of microorganisms? And it seems obvious to us today, but in those days when they didn't understand the processes of microorganisms, it was a difficult question to prove. But he was able to demonstrate that yeast, microscopic fungi, actually produced wine and produced alcohol, whereas certain kinds of bacteria produced the vinegar. And it got scientists thinking at the time. They had this kind of collective, like, oh, around 1857, about 10 years after Semmelweis, when they said, if microorganisms can spoil wine, maybe they can also cause harm in living organisms, and they can cause disease. And so this idea that's been demonstrated over and over again is that microorganisms cause disease. We now call the germ theory of disease. And the disadvantage Semmelweis had was he couldn't link bacteria or microorganisms to these infections and tell people why they were washing their hands. But shortly after Pasteur and others demonstrated that microorganisms could change things, people started looking at microorganisms and disease. Another scientist that was really big at the time was Robert Koch, and he was big on the germ theory of disease and is really well known for a lot of experiments. We just don't have too much time to talk about him. But the other person I do want to talk about is Joseph Lister. And so now we're into the 1860s, and mostly the later 1860s, where Lister, who was a surgeon, his main surgical procedure was amputations, because around his time there wasn't very much anesthesia available yet. It was still just being developed, and people could break bones. The bone pops to their leg, and you have no choice. Usually, what happened is they did amputations, and a dramatic percent, like a very high percentage of people, about 50% of people would die from these surgeries. And we now know they died from infections. So what Lister did is he took a chemical called phenol and started spraying it on the patients, on the equipment. The surgeons washed their hands with it and all, and they used that to kill microorganisms. When they did surgery on their patients, the amount of death dropped dramatically. And this was something that people noticed immediately. And Lister was embraced by the public, and his techniques were adopted very quickly. So Lister and Semmelweis were doing very similar things. But Semmelweis did his before we started understanding the germ theory of disease. And Lister's practices were much more widely accepted. And the germ theory of disease continued to be a really important, and continues today to be a really important part of public health. And many people have studied it and continue to study ways to control microbes and disease.